In this video, we are going to talk about hypothesis testing for proportion or percentage, okay? In chapter 7, you saw the confidence interval for proportion, but here we will discuss about the hypothesis testing of the proportion. So in the previous videos, we did hypothesis testing for the mean when population standard deviation is given and when population standard deviation is not given. In the case of population standard deviation given, we call that as G-test. And in the case of population standard deviation not given, we call T-test. But for the hypothesis testing of the proportion, we don't have G-test or T-test. We call hypothesis testing for the proportion, okay? So we will do two methods. One is the traditional method and the other is the p-value method. Okay, so let us talk about the steps of the. Oh, by the way, this is not right. This is not t-test for the mean. This is the hypothesis testing for the proportion. Okay, in the traditional method, we first write H0 is the null hypothesis and H1 is the alternative hypothesis. Okay, and then next we find out the test statistic or test value. The formula is we denote T or Z, okay, by P hat is the sample proportion. So P hat is proportion of the sample, that is X over N. X is the observation, N is the total sample size, minus P is the population proportion over under the root P times Q over N. What is Q? Q is 1 minus P. That's the formula. So P is population proportion, Q is 1 minus P, but P hat is the sample proportion, okay? N is the sample size. So N is sample size. Sample size. Okay? And step number 3 is find the critical values. The critical value, to find out the critical value, it is exactly same as how we find the critical value for the G test, meaning hypothesis testing for the mean when sigma is given. Exactly the same value there, okay? You use inverse norm, and then if the test is left tail, you inverse norm, you do alpha. If the test is right tail, you do inverse norm 1 minus alpha, or you can do alpha and then you get negative, but this one is negative there. For the left tail test, you will get negative there. For the two tail test, what we do, you just divide alpha half, right? What we do here, let me make the figure for that. This is the left tail test, okay? Alpha is in the left. You need to find out G alpha negative. For the right tail test, what you do is, if you want to find out right tail test, is basically you enter that as alpha, right? You need to find out positive G alpha, not G alpha, positive G alpha, okay? So in this case, what is the left? Because your inverse norm needs the left area. So what is this left area? So 1 minus alpha will be the left area. If alpha is 0.05, 1 minus alpha will be 0.95. That will give you that value. And for the right critical value for the two-tail test, this is for the right or left, whatever you do. You can find out the left critical value, and for the other one, you do the same number with the sign change. What does that mean? That means here this is the two-tail test, so alpha is divided to 2 halves. So this is alpha half, this is another alpha half, right? So this is positive G alpha half, this is negative G alpha half. G alpha half, okay? I think this one is 1 minus alpha, okay? 1 minus alpha here, 1 minus alpha, not alpha only. So negative G alpha half is inverse norm, and then you can do alpha half only for negative one. For positive, you do inverse norm 1 minus alpha half. That because the right area is alpha half, so the total left is 1 minus alpha half. Or what you can do is minus G alpha half equals to inverse norm, and then alpha half, and then 0, 1. If you do that, it will give you negative G alpha half. Or you can find positive this one by using that formula. And decision is again if the test statistic, the value from the step 2 fall in this shaded region, then you reject the null hypothesis. Otherwise, we do not reject. For the p-value method, all the first and second steps are same. Only the third step is you need to find out the p-value. So we need to do the normal CDF because it is exactly same as the G test. Okay, it is exactly same as the G test. We do find the area left of the test value or find the area right of the test value, or 2 times the area left or right of the test value depending on the sign of the test value. Okay, and we do the decision. So let us see some examples, then things will be very clear. Okay, let us do example number 1. So first of all, we will write down the given stuff here, and then we will do the hypothesis testing. Okay, let's write down the given thing. A researcher claims that based on an information obtained from Center for Disease Control and Prevention, 17% of young people between age 2 and 19 are obese. So what is the proportion of the population that are obese? Is P equals to 0.17. This is the population proportion, population percentage, and it is the claim. Because the question says a researcher claims that. That's why it is the claim, okay? And then it does not say anything about the sample so far. Up to here, it doesn't say anything about the sample. Meaning, any information given before these are the population, are for the population, okay? Now, to test these claims, she randomly selected 200 people. That means N equals to 200, okay? Between age 2 and 19, and found that 42 were obese. So X is 42, okay? Sometimes a sample proportion P is given to you. Sometimes a data will be given to you. You will have to find out P, okay? So what is alpha? Alpha is 0.05. And then it says, is there enough evidence to reject the claim? It doesn't say less than or greater than here, meaning it is the two-tailed test, right? So what will be the P not equals to 0.17? That will be the two-tailed test. But what is P hat? Because the formula needs P hat. P hat is the sample proportion. The formula is X over N. That is P hat. So X is 42 divided by N is 200, right? Isn't that 0.21? That is 21%. In the sample, they found 21%, but in the population, the researcher claimed that the total percentage of the obese kids are 17%. Now, based on the sample, can we claim that? Can we find a conclusion whether we reject the null hypothesis or not? That's what we are going to test, okay? So let us do all the steps. Step number 1 is write down H0 and H1. H0 is the null hypothesis. We usually write equal to sign. That is here, that is given, right? P equals to 0.17. This is the claim. Okay. Again, usually claim is alternative hypothesis, but sometimes a claim is given as the null hypothesis. Null hypothesis, the question give you that this is the claim, like that, okay? In that case, null hypothesis can be the claim. And H1 is, since it is the two-tailed test, P is not equals to 0.17. And you should be careful on this. In the null and alternative hypothesis, we use exactly the same numbers on the right side. 0.17, 0.17. Don't use 0.21 in any of these null and alternative hypothesis, okay? So this is two-tailed. Meaning we will have to divide alpha into 2 halves, right? Because it is not equals to. If it was greater than, then it would be right tail. If it was less than, it would be left tail. But it says not equals to, because it didn't say less than or greater than. That's why it is not equals to. Okay. Number 2, we find out the test value. Test value. We denote G or T. You can write capital T equals to P hat minus P over under the root P times Q over root N. Okay. So what is P hat? 0.21 minus 0.17 divided by root under. What is P? P is 0.17. 0.17 times Q is 1 minus P. That will be 0.83, right? That's what you get. Divided by N is 200. So in the calculator, what we do is we enter that, but there are 2 terms on the top. So we start with parenthesis, 0.21 minus 0.17 divided by under the root, okay, 0.17 times 0.83 and then divide by 200, okay. That is the test value. Let me hit enter. What do we get? We got 1.51, right? That's what I got, 1.51. If I round it up to 2 values, 1.51. That is the test value. Let us find out the critical value, okay? The next step is finding the critical value. How do I do that? Is number 3 is critical value. Critical value, we will draw this because this is the two-tailed test. It will be easier if you draw. Two-tailed test, 0 is in the middle. So that alpha half and another alpha half like that. So alpha is 0.05. So alpha half is 0.025. This is 0.025. This will be 0.025. So this will be negative G alpha half. This will be positive G alpha half. So how do I find out negative G alpha half? Is enter the left area in the inverse norm, right? Inverse norm and then 0.025 and then 0.1, right? If you do that, what do you get? Let us use calculator for that too. So we go to second verse. You get inverse norm in number 3. Hit enter. Area is 0.025, right? And then mu is 0, sigma is 1. If you hit enter on the pairs, that's what you get, negative 1.96. So this value is negative 1.96. So this is negative 1.96, right? And this is positive 1.96. Now, so how do we make the decision? Number 4. Number 4 is decision. So all the steps of the hypothesis testing are same, only the number 2 is different because we have a different formula for the test value, right? So decision is, so how do I write the decision? Is the test value fall in the shaded region or do not fall in the shaded region? This is 1.51. So anything right of the 1.96, anything bigger than 1.96 and anything smaller than negative 1.96 they fall in the critical region or the shaded region. But this value will fall somewhere here, right? 1.51. So that's why since the test value fall in not shaded region, or you say test value does not fall in the critical region. I think that is better way to say that, okay? Since the test value, you can say does not fall in the critical region, value does not fall in the critical region, we do not reject H0. So we do not reject means we actually support, basically support the H0. That is the indirect way of saying that. That means the claim that the 17% of the young people between age 2 and 19 are obese is basically, that claim looks like that is true, right? So what we can say is there are enough evidence we do not reject, right? Enough evidence to support the claim, right? To support the claim. Or what is another way of saying that? You can say there are not enough evidence to reject the claim. You can say that way too. There are not enough evidence to reject the claim. Okay. So this is how we do it by the critical value method. The another method is p-value method. I'll show you. But let us do this first example using the calculator directly. I can do that too, okay? So how do I do that? Go to stat and then test, right? So this is the proportion test, right? What we do is, look at that, 1 proportion G test, number 5. This is basically G test because we use exactly same method to find out the critical value. We call G test. So its name is 1 proportion G test. Let's do that. So what is P0? P0 is basically 0.17, right? So we do 0.17. That is P0 is 80. What is X? X is 42. That is the value of the observation. And then what is N? N is 200, right? Is this left tail, right tail, or two tail? This is the two tail. So I am picking the first one and go to the calculate and hit enter. You get P value is negative 1.3. The test value is 1.50. Test value is 1.50 here. We got that 1.51 basically. Actually 1.51 because if you round it up, right? And the p-value, we did not find the p-value in this problem. We did the traditional value method or the critical value method, traditional method. So if you find it, you will get 0.13, which is a lot bigger than alpha. Alpha is 0.05, right? Alpha is 0.05. This p-value is bigger than alpha. So what is the decision criterion for the p-value method is if p-value is less than alpha, we reject the null hypothesis. But if p-value is greater than alpha, we do not reject the null hypothesis. Here we got the p-value greater than alpha, so we do not reject the null hypothesis. This is how we do using the calculator. Okay. So let us see one more example here. That example I think asks you to do the p-value method, I guess. Not really. So it doesn't say any method here. So what I will do for this is I will do by using calculator only, or I can do the traditional method again. Let's do traditional method. It's not a big deal, okay? It is a little bit long because it has steps. P-value method also has a similar steps, but if you do by calculator, you can find out the answer directly, okay? Let us do this. Example number 2. About 30% of all burglaries are through an open or unlocked door or window, okay? So what is that? This is the population proportion because it doesn't talk about sample on this far, okay? So the right is p equals to 0.3, okay? A random sample of 130 burglaries indicated that 85 were not, look at that, 30% are from open door or window, but 85 were not from open door or window. That's what he's saying. So what is the x? X must be out of 130, 85 were not from open door or window. But the question is giving about 30% are from open door or window. So how many were from open door or window then? So 130 minus 85, right? That will be 45. So 130 minus 85 equals to 45. The reason why we have to deduct, we have to subtract is because the first sentence give for open door or window. The second sentence give, the sample gives not from open door or window. That means they are the 130 minus 85, that is 45 were from the open door or window. So n is 130. So what is p hat? That will be 45 over 130, right? If you use calculator, what do you get? So 45 over 130 will be 45 divided by 130 is 0.3461. That is 0. You can write 3461 here, or you can write 35. Okay. So what is alpha? Alpha is 0.05. Let us see whether it is left tail, right tail, or two tail here. Okay. So I mean, whatever method you apply, actually you need to list the given things first. Okay. So it says at 0.05 level of significance, alpha is 0.05, can it be concluded that this differs from the stated proportion? Okay. So it says it is two-tailed, right? So it will be p not equals to 0.3. So it is two-tailed. Two-tailed. Which one is claim? Does it say anything claim? It doesn't say. The first sentence doesn't say claim. So it is the claim will be the alternative hypothesis. So that will be claim. We'll assume. Okay. So do exactly the same steps. Number one, H0 is p equals to 0.3. H1 is p not equals to 0.3. Right. Number two is the t or z. The test value is p hat. What is p hat? Is 0.3461 minus 0.3 divided by p is 0.3. Q is 0.7 because that is 1 minus p. 0.7 divided by 130. If you do that, what do you get in your calculator? So you will get 0.3461 minus 0.3 divided by under the root 0.3 times 0.7 divided by 130. 1.1469. So that is 1.1469. That's what I get. Okay, that is the test value. So if you want to do the number three, the traditional method, so we have alpha equals to 0.05 and then two-tailed, right? Two-tailed. So what do you have, how do I find out that? You just draw that and then set in both sides. So that is alpha half is 0.025 and this is also 0.025. So this is positive G alpha half, this is negative G alpha half, right? So how do you find out negative G alpha half? Is inverse norm, right? And then what is that? 0.025 and then 0,1, right? If you do that, you will get negative 1.96. So this will be negative 1.96. The other one will be positive 1.96. 96 negative and then 1.96. Do you think that the test value fall in the shaded region? The answer is no, because 0 is in the middle. This is smaller than the bigger value and bigger than the smaller value. That means bigger than the negative value. So it will be somewhere here. That is the T. So number 4 is we do not reject the null hypothesis. Do not reject H0, meaning there are enough evidence to reject that claim, right? Because it is two-tailed and this is claim. So there are enough evidence to reject the claim. So there are enough evidence to reject the claim. That the burglaries so to reject the claim that the percentage of the burglaries from open door or window is different from 30%. Okay, let us do last example for the hypothesis testing of the proportion. Okay, this may be different from other two because other two were two-tailed test, example 1 and 2. So this will be one-tailed test. Okay, first of all, let us read the question and then report or note down the given things. Okay, a survey by Men's Health magazine claims that at least 14% of the men said they used exercise to reduce the stress. Okay, that's their claim. That they claim that in the population, at least means greater or equals to more than or equals to 14% means 0.14. That's their claim, right? But use alpha equals to 0.10 and a random sample of 100 men was selected and 10 of them said that they used exercise to relieve the stress. So use the p-value method to test the claim. Could the result be generalized to all adult Americans? Okay, let us see that. So what is given is P is greater or equals to 0.14. So this is the null hypothesis, right? Because this is talking about the population. So this is the null hypothesis and it says greater or equals to. Although we write equals to, so greater or equals to is basically the null hypothesis. But what will be the alternative hypothesis? Alternative hypothesis must be less than that because opposite of the null hypothesis is the alternative hypothesis. So alpha is given as 0.10, right? So n is 100, x is 10. So what will be p hat? P hat will be 0.10 because x over n, 10 over 100 is 0.10. So we need to use the p-value method. So this will be two-tailed. So this is claim because claim is given as at least 14%. So it is two. So let's write down all those things. Number 1 is 80 is p greater or equals to or equals to 0.14. That is claim. Although it is greater or equals to, people also write equals to for the null hypothesis. Okay, claim. And H1 is P less than 0.14. Okay, that is left tail, right? Left tailed. Now number 2 is T or G. Test value T or we denote also by G. So P hat minus P over root under PQ over N, right? So if you do that, you'll get 0.1 minus 0.14 divided by 0.14 right? And then 0.86 over n is 100, right? Let us use calculator. How much is that value? So 1 minus 0.1 minus 0.14 divided by under the root 0.14 times 0.86 divided by 100. That's what you get. If you hit enter, you get negative 1.1527. Negative 1.1527. Okay, now in number 3, what we do is we find out the p-value. This is left tail test. Alpha equals to 0.10, and then left tail. What does that mean? What we do is we draw this normal curve. Okay, 0 is there. Where is t? That t test value falls somewhere on the left side, right here. And what you do is, this is negative 1.1527. So our goal is to find out this area, right? We want to find out that area. What is the area left of negative 1527? That's what you do. That is the p-value. So that is the p-value. Area left of that is the p-value, right? This is not alpha. Alpha is given as 0.10. So we want to find out the p-value. That is the area of the shaded region. So p is area left of negative 1.1527. Okay, so that will be if it was two tail, we will have to set both sides basically in the critical value method. But here you don't have to. Basically you will have to multiply by 2 times in case of the two tail. 2 times area left of this in case of the negative test statistics. If it was a positive test statistics and if it was two tail test, we would have to do 2 times area right of that. Okay, so how do I do that? Is normal CDF negative 10 to the 10 comma negative 1.1527 and then 0 comma 1. Let us use calculator to find out that. So if you use calculator, you get second verse and then normal CDF. So that will be negative 10 to the 10 and negative 1.1527, right? And then 0 and then 1 and then paste, right? What you get is 0.1245. That's what you get. 0.1245. Number 4 is decision. Is p-value less than alpha or greater than alpha? P-value is greater than alpha. So we do not reject 80, right? In this case, we do not reject. How do you write the conclusion? Conclusion is we do not reject means we basically support the claim, right? Or there are not enough evidence to reject the claim. That's what it says. So hence there are not enough evidence to support the claim. To reject the claim. I'm sorry, because we are not rejecting, right? To reject the claim. To reject the claim that the proportion of the people, you keep writing, okay? The proportion of the people who use exercise to reduce the stress is 14%. That's how you write. Okay, guys? Thank you.